Now we will see first problem. E to the power of tan inverse x by 1 plus x square into dx. This is the problem. Now we are going to put tan inverse x is equal to t. 1 over 1 plus x square, differentiation of this is 1 over 1 plus x square is equal to dt by dx. Now you will take this dx to top, it becomes dx by 1 plus x square is equal to dt. See here dx by 1 plus x square will be equal to dt, e to the power of t, integral e to the power of t dt. Now which is equal to e to the power of t itself. Our answer is e to the power of tan inverse x plus c is the answer for this problem. Now we shall see second problem. Integral e to the power of 2x minus 1 divided by e to the power of 2x plus 1 into dx. E to the power of 2x minus 1 divided by e to the power of 2x plus 1 into dx. Now I am going to split like this. E to the power of 2x by e to the power of 2x plus 1 minus into dx minus 1 over e to the power of 2x plus 1 into dx. Can we do it like this? Now first part of the problem I am going to do like this. Put e to the power of 2x plus 1 is equal to t for the first part of the problem. See, this becomes 2e to the power of 2x is equal to dt by dx, or e to the power of 2x into dx is equal to dt by 2. Now what happens to this we will see now. Integral e to the power of 2x dx, e to the power of 2x dx is dt by 2. I will take off dt divided by t, because e to the power of 2x plus 1 what we have kept? It is t minus. Now this we are going to do it separately, afterwards we will come to that. Now this is nothing but half log t. This is nothing but half log t minus this. I am going to do it like this. E to the power of x whole square plus 1 into dx. E to the power of x whole square plus 1 into dx. Now this is equal to half of log e to the power of 2x plus 1, half of log e to the power of 2x plus 1 minus this is nothing but tan inverse e to the power of x whole thing plus c. This is the answer. Next, third problem. Integral e to the power of 2x minus e to the power of minus 2x divided by e to the power of 2x plus e to the power of minus 2x dx. Now put, this is very easy, put e to the power of 2x plus e to the power of minus 2x is equal to t. Now individually differentiate. 2e to the power of 2x minus 2e to the power of minus 2x is equal to dt by dx. Now I will take out common 2 e to the power of 2x minus e to the power of minus 2x now into dx is equal to dt. I have cross multiplied this. Therefore e to the power of 2x minus e to the power of minus 2x is into dx is equal to dt by 2. I am sorry, it minus 2x into dx is equal to what? It is dt by 2. So integral of dt by t, because we have kept this as t. Therefore, this is equal to half log t plus c, or log of root of t plus c. Because it goes to the top, t to the power of half, it becomes root. Therefore, log of e to the power of 2x plus e to the power of minus 2x whole to the power of half plus c is the answer for this. Now, fourth problem, integral tan square 2x minus 3 into dx. This is the problem. Here also, put 2x minus 3 is equal to t, 2 into dx is equal to dt, or dx is equal to dt by 2. When we differentiate this, we get dx is equal to t by 2. Integral tan square t dt by 2, that is half of integral tan square t into dt. See, as it is, we cannot integrate this. For this, what we are going to write? We are going to write the formula secant square t minus 1 is the formula for this. Tan square theta is equal to secant square theta minus 1. Now, half of integral secant square t dt minus integral 1 into dt. Now, half of, how much is this? It is tan t. Secant square t dt is tan t minus t. Therefore, half of this is plus c. Tan of t is how much? 2x minus 3 minus 2x minus 3 plus c is the answer of this. Now we will go for last problem. Integral sin inverse x divided by root of 1 minus x square into dx. Integral sin inverse x by root of 1 minus x square into dx. Now put sin inverse x is equal to t. When you differentiate this, differentiation of sin inverse x is 1 over root of 1 minus x square is equal to dt by dx, or dx by root of 1 minus x square is equal to dt. See, when we differentiate sin inverse x, 1 over 1 minus root of 1 minus x square is equal to dt by dx, or dx by root of 1 minus x square is equal to dt. As such, integration dx by root of 1 minus x square is equal to what? It is dt. Therefore, integral t dt. Because sin inverse x is t, this is dt, t dt, which is equal to t 1 plus 1 divided by 1 plus 1 plus c, or t square by 2 plus c, or half of sin inverse x whole square plus c. This is the answer for this. Now, fourth problem, integral tan square 2x minus 3 into dx. This is the problem. Here also, put 2x minus 3 is equal to t, 2 into dx is equal to dt, or dx is equal to dt by 2. When we differentiate this, we get dx is equal to t by 2. Integral tan square t dt by 2. that is half of integral tan square t into dt. See, as it is we cannot integrate this. For this what we are going to write? We are going to write the formula secant square t minus 1 is the formula for this. Tan square theta is equal to secant square theta minus 1. Now half of integral secant square t dt minus integral 1 into dt. Now half of, how much is this? It is tan t. Secant square t dt is tan t minus t. Therefore half of, this is plus c. Tan of t is how much? 2x minus 3 minus 2x minus 3 plus c is the answer for this. Now we will go for last problem. Integral sin inverse x divided by root of 1 minus x square into dx. Integral sin inverse x by root of 1 minus x square into dx. Now put sin inverse x is equal to t. When you differentiate this, differentiation of sin inverse x is 1 over root of 1 minus x square is equal to dt by dx, or dx by root of 1 minus x square is equal to dt. See, when we differentiate sin inverse x, 1 over 1 minus root of 1 minus x square is equal to dt by dx, or dx by root of 1 minus x square is equal to dt. As such, integration dx by root of 1 minus x square is equal to what? It is dt. Therefore, integral t dt. Because sin inverse x is t, this is dt, t dt, which is equal to t 1 plus 1 divided by 1 plus 1 plus c, or t square by 2 plus c, or half of sin inverse x whole square plus c. This is the answer for this. Now we will see the first problem here. Integral 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x dx. See here, I am going to take common here. 2 cos x minus 3 sin x divided by, in this I am going to take 2 as a common. We will take 3 cos x plus 2 sin x, it will come. So now into dx. Now I am going to take half outside. Now 2 cos x minus 3 sin x by 3 cos x plus 2 sin x dx. Now put 3 cos x plus 2 sin x is equal to t. Differentiating, this becomes minus 3 sin x plus 2 cos x is equal to dt by dx, or we will write like this: 2 cos x minus 3 sin x into dx is equal to dt. Minus 3 sin x plus 2 cos x is equal to dt by dx, or 2 cos x minus 3 sin x into dx is equal to dt. Now I am going to Here substitute here, 2 cos x minus 3 sin x into dx is what? It is dt. So half of integral dt by t, which is equal to half of log t plus c. This is equal to log of t to the power of plus half, or it is root 2, root t. So log of, answer is log of root, how much it is? T is equal to what we have kept? 3 cos x plus 2 sin x plus c. This is the answer. So we will go for second problem. Integral cos root x by root x dx. Put root x is equal to t. 1 over 2 root x is equal to dt by dx. Or dx by root x is equal to 2 dt. 2 root x, 1 over root x dx, dx by root x is equal to 2 dt. Now I am going to substitute here cos t, root x is equal to what we have kept here? T, cos t, 2 into dt, or 2 you take out common, cos t dt. What is integration of cos x with respect to dx? It is sin x. 2 sin t plus c, or 2 sin root x plus c. This is the answer for this problem. So now we have finished this second problem. Now we will go for third problem. Root tan x by sin x cos x with integral dx. Can you see here? Integral root tan x by sin x cos x dx. Now here multiply and divide by secant square x. This adjustment we are going to do it here. Here integral root tan x secant square x divided by sin x cos x. Instead of secant square x, I will write 1 over cos square x, because 1 over cos square x is secant square x into dx. Now what happens to this? This and this get cancelled. Therefore what do we get? Root tan x secant square x dx divided by tan x. Are you following here? Sin x by cos x is tan x. Now we will take it to the top. It becomes tan to the power of 3 by 2x into secant square x dx. Because here it is tan to the power of half plus 1 is nothing but tan to the power of 3 by 2x secant square x dx. If you want, we will prove it separately here. I will show you tan to the power of tan x whole to the power of half into tan x is nothing but tan x whole to the power of 3 by 2. I have shown here. See, this is nothing but 1. 1 plus half is 3 by 2. So that is what we have shown here. Put tan x is equal to t. Now secant square, differentiating secant square x dx is equal to dt. Secant square x dx is equal to dt. Therefore t to the power of 3 by 2 dt. T to the power of 3 by 2 dt. Now this is equal to t to the power of 3 by 2 plus 1 divided by 3 by 2 plus 1 plus c, or t to the power of 5 by 2 into 2 by 5 plus c. This is equal to 2 by 5. What is t is equal to? We have kept tan x. So tan x whole to the power of 5 by 2 plus c is the answer for this problem. Thus, we have finished this third problem also. You can see. Now we will see fourth problem. 1 over 1 plus cot x dx. The integral 1 over 1 plus cos x by sin x dx. We are going to take LCM. It becomes sin x by sin x plus cos x. It becomes sin x plus cos x. Now what we are going to do now, you can see here. See, one adjustment we are going to make. Here sin x plus cos x by sin x plus cos x minus, here we will do here, minus cos x plus sin x by sin x plus cos x into dx. See, any doubts here? See, it is nothing but we are going to minus cos x minus sin x divided by sin x plus cos x we have done. We have not done any change here. Sin x plus cos x, you can remove the bracket. Cos x minus cos x cancel, minus plus 2 sin x you will get. For that what we do here, we will make it off. So off into 2 sin x, 2 cancels. Therefore you are left with sin x by sin x plus cos x. Now this adjustment we are going to do. See, this cancels. 1 into dx minus integral cos x minus sin x by sin x plus cos x dx. Now here for this what we are going to do, we are going to put sin x plus cos x is equal to t. Put sin x plus cos x is equal to t. Now what happens here? It becomes cos x minus sin x into dx is equal to dt. Are you following here? Only for this adjustment we are doing, not for this. Now it is nothing but half of this becomes x minus, you can see here, it becomes dt by t. Will you agree? dt by t with integral. So this is equal to half of x minus log t plus c, or this is equal to half of x minus log of, now going back to t, substituting that value of t is equal to sin x plus cos x here. We are substituting sin x plus cos x plus c. This is the answer for that. See, now we have finished fourth problem and we have taken fifth problem. Integral 1 over 1 minus tan x, similar to 1 over 1 plus cot x. But here 1 over 1 minus sin x by cos x, which is nothing but integral cos x by cos x minus sin x. See, here we are going to do this adjustment here. Half of cos x minus sin x by cos x minus sin x plus cos x plus sin x by cos x minus sin x. See, when we remove the bracket, sin x cancel, 2 cos x you will get, 2, this 2 cancel, cos x by cos x minus sin x you will get. So this is the adjustment we have made here. Now for this it is 1 into dx. This cancels, no? 1 into dx plus, for this put cos x minus sin x is equal to t. Therefore minus sin x minus cos x is equal to dt by dx. Minus of sin x plus cos x into dx is equal to dt, or sin x plus cos x dx is equal to minus dt. Cos x plus sin x dx is equal to minus dt. That we have kept here. Integral minus dt by t. So minus log t. So this is x minus log t, or x minus log of t. What we have kept here? Cos x minus sin x. We are going back here. Cos x minus sin x plus c. So this is the answer. Now we have finished this fifth problem. Now sixth problem we are going in. Integral x cube sine of tan inverse x to the power of 4 whole divided by 1 plus x to the power of 8 into dx. This is the problem. See, x cube sine of tan inverse x to the power of 4 divided by 1 plus x to the power of 8 into dx. Now with this I am going to write like this. X cube sine of tan inverse x to the power of 4 divided by 1 plus x to the power of 4 whole square. Is it okay? X to the power of 8 can be written as x to the power of 4 whole square into dx. Now I am going to put x to the power of 4 is equal to t. Now when we differentiate this, 4x cube is equal to dt by dx. dt by dx, or x cube into dx is equal to dt by 4. Now x cube into dx is equal to what? It is dt by 4. I am going to write dt by 4 into sine of, what is this is equal to? Tan inverse t. X to the power of 4, what we have kept here? It is t, sine of tan inverse t, divided by 1 plus x to the power of 4, how much we have kept here? T. So this becomes how much? T square. Agreed? So dt by 4, because x cube dx, sine of tan inverse x to the power of 4 is t, divided by 1 plus x to the power of whole square is nothing but t square. Now what I am going to put? Again put tan inverse t is equal to z. 1 over, when you differentiate this, 1 over 1 plus t square is equal to dz by dt, or dt by 1 plus t square is equal to dz. So dt by 1 plus t square is how much? Dz. Now integral dz, we will write 1 by 4 here. This 1 by 4 I have taken. We will write sin z dz. Will you agree? Sin z into dz. So what is integral sin z dz? Minus cos z plus c. That is minus 1/4 cos of z plus c, or minus 1 by 4 cos of z is equal to what we have kept here? Tan inverse t plus c. But what we have kept here. X to the power of 4 plus C. I think you can see here, for dz we came back to, instead of z, what we have to put here, tan inverse t, that we have replaced here. Instead of z, it is tan inverse t. Again, for t, we have to replace this by x to the power of 4. We have to come back to this. So tan inverse x to the power of 4 plus t. See, original problem is in x. So we have all together, we have come back to the original problem. So this is the answer for that problem. So much you have to do.